Hello, my name is Alonso Garcia, and my topic is conservation of energy. Energy. It is one of the most basic principles of physics, and Albert Einstein explains it as energy cannot be created nor destroyed. It can only be changed from one form to another. Okay, so the needed knowledge in order to understand this topic is that there are many different forms of energy like kinetic, potential, thermal, chemical, electrical, nuclear, mechanical, and many others. And when they change from one form to the other, the same amount of energy will remain there from beginning to end, and no actual energy gets used up or becomes non-existent. For example, here in the picture, uh, to the right there is a sun which is giving off light energy and a solar panel which is turning that light energy directly into electrical energy, which is powering the light bulb, which then turns it into either heat energy or light energy. But all the energy just gets transformed, nothing actually gets lost or destroyed. Some important definitions in order to understand this topic are conservation of energy, which was on the second slide and was told by Albert Einstein, and a closed system is a system that is isolated or a physical system that doesn't exchange any matter with its surrounding and isn't subject to any force whose source is external to the system. And also to the right it shows an open system is a system that is affected by the environment surrounding it, and a closed system has no environment to affect it, and what goes on inside the circle stays in the circle. Okay, so you might be asking yourself what sort of equations this conservation of energy has. Well, it actually doesn't have any equations. Conservation of energy does not have its own equation, but instead it is a principle that is the basis for other equations on energy in order to solve energy problems. Okay, let me move on to explanations of conservation of energy. In a closed system, when energy is changing from one to another form of energy, the total amount of energy that was in the system stays the same. For example, in the picture, the energy goes in and the same amount of energy goes out. Okay, let me give an example. If I let a bouncy ball said to be inelastic drop in a closed system, the ball should bounce back up to the original height, meaning that the ball will not be affected by things like air resistance. The reason why the ball bounces back up to the original height is because of conservation of energy. Immediately before the ball drops, it mostly only has potential energy, and as the ball drops, the potential energy becomes kinetic energy as it falls, and by the time it bounces back up and reaches the original drop height, the ball will retain all the potential energy it did before. The equations that would be used in the previous scenario are as follows. The potential energy is equal to kinetic energy, which is in this case an equation that symbolizes conservation of energy. And kinetic energy is equal to 1/2 mass times velocity squared. And potential energy is equal to mass times gravity times height. So if the second and third equations were to be substituted into the first, then the full equation of conservation of energy in this case would be 1/2 mass times velocity squared is equal to mass times gravity times height. And then that would be what to use to figure out how much potential or kinetic energy the ball has, if that were a question that it was asking. And that is basically all there is to conservation of energy. That's all, folks.